Okay, now that you've got everything set up, let's go ahead and initialize and configure the router to get ready to do the OpenShift installation. Okay, so first thing we're going to need to do is plug in your router if it's not already plugged in, and then from your workstation, you're going to want to connect to it either directly via cable. You can jack straight into one of the LAN ports if you want to, and stay on your home network Wi-Fi for this step. Or what I'm going to do is I'm going to directly connect to the router, which is going to show up right here. It's that GL AXT 1800-8A5 5G. You'll find the network password for your router on the bottom side of it. If you flip it over, a little white sticker on the bottom. So you can get connected directly to the router, directly initialized. So there's nothing on it yet except for the factory configuration. So I'm not connected to that router. First thing I'm going to do, because that router comes up on 192.168.8.1, I'm going to make sure that I'm connected to it. And there we go. We've got good pings. Okay, so before I do anything else with that router, I want to copy over my public SSH key to that router. So I'm going to do an SSH command and pass that over there. I'm going to say, yes, I want to trust that. Okay, so now I've put my SSH key over there. All right, I'm doing that before I do any other configuration on the router, just because at this point the router has no password configured. So I could very quickly and easily send that public key over. Now, log into the router on 192.168.8.1, and it might come up with initially with a self-signed cert, so you'll need to trust and bypass that. But now I'm logged into the router. Let's walk through the configuration. I'm going to use English as my language. I'm going to choose my own password here instead of letting the MacBook choose a new one, because I'm going to use a password that I've already got configured for this router. But go ahead and set up a administrative password if you're going to use this GUI, and apply that. Now that we're in the settings for the router, we need to get internet connection back, because the next step we're going to run is going to need internet connection. So what I'm going to do is set up repeater mode on this router and connect to my home Wi-Fi network via the repeater. So we'll give it just a minute here to identify the networks that it sees floating around. And this can take a minute or two while it scans. Okay, and there we go. It found one, because as you can see, I'm out in the middle of nowhere here, sitting out in the woods. So I'm going to connect to that. I'm going to put in the WPA password for my home network. And I'm going to let this router connect. All right, now while it's doing that, it may or may not drop my connection. So I'll need to watch my Wi-Fi connection, and there it goes. See, it just dropped. So rather than it reconnecting to my home network, I want to stay connected to this router. So I'm going to select the router's network again. And when it comes back, we should see hopefully a successful connection to the internet. We'll give it just a minute here to refresh. Yep, there it rebooted itself. So I'll reconnect to that again. You might have to do that a couple of times because it goes through a couple of cycles, and there it is. So it is now connected to my home internet. I'm going to come back over here, make sure I have DNS resolution and I can ping. Okay, so I do have internet connection restored. Next thing we're going to do is run one of my lab scripts. And this is context setting. So we're going to set the lab context to be our OpenShift cluster that we're going to build. Now, when you run this the first time, it's going to take a little bit because it's going to download the utilities that it needs. It's going to download the butane utility. It's going to download the OpenShift command line interface, OC, kubectl, and OpenShift install. It's also going to download and install the network configuration command line interface that we're going to need. So this is going to take a little bit. I'm going to pause the recording at this point for just a bit so that you don't have to just stare at a screen doing nothing, and we'll come back when it's complete. Okay, as you can see on my screen now, it has finished downloading all of the artifacts that it needed. I'll show you over here real quick some of the things that it did. You see this new folder that was created, OpenShift commands. And there's a the init here is because it needed to bootstrap. It didn't find an OC command, and it needs an OC command in order to download the artifacts to get the correct OC command line interface and OpenShift install interface and everything for this version of OpenShift. So what I did is I pulled the OC from upstream from GitHub from an OKD release to use that to then bootstrap the artifacts that went into this 4.15.11 x86-64 folder. So there's kubectl, OC command line interface, and OpenShift install command line interface that are from the bundle for installing this particular version of OpenShift. It also downloaded the version of nmstate-ctl CLI that we need, as well as butane, version 0.20.0 of butane. So it pulled down all of these artifacts that we're going to need to run the installation. But before we do that, we need to finish setting up the router. The router needs the personality that we're going to give it for this lab. So in order to do that, now that the context is set, and if you run a quick env, you'll see a whole bunch of environment variables that have been set for you. This is what the next scripts are going to do to set up the personality for the router. So what we're going to do is run my lab CLI command against the router, and we're going to tell it to initialize the router for an edge network, okay? Actually, before I'm going to run that command, let's just double check that we're still connected to the internet, because we need to be connected to the internet for this to complete. All right, and we are. So I'm going to run the initialization command, and you'll see here some of the things that it does. So see, it's going out to ipixie.org. It did a quick install. It pushed some files over there. It changed some configurations. So it turned off some of the utilities that come with this GL router. One of the main things is that when you plug in a micro SD card, it's going to try to auto mount that to a prescriptive location so it can use it for NAS. We don't want it to do that. So one of the things my script is doing is shutting down all of this NAS stuff. If you paid attention, you'll see up here that I'm disconnected from Wi-Fi. That's because the router rebooted when it finished this particular stage of the configuration. When we run the next stage of the configuration, it's going to reboot again. Something else I'll point out is that we generated an ED255519 SSH key pair for this router. So now it has its own SSH key. And as soon as we get reconnected to the internet, it will take it a couple minutes to boot, but you can see there it is, it's back. We'll see if we can reconnect or if it's still initializing. Give it just a minute here. Okay, it looks like we're reconnecting. Okay, so the router has now rebooted. The router is no longer at 192.168.8.1. The router is now, in fact, 10.11.12.1. Okay, so the router also now has new network information configured with it. I'm going to make sure we still have internet connection, and we do. So the next step is to complete the setup of the router. Now, this next step is going to install a whole bunch of software. It's going to install bind for DNS. It's going to install a bunch of Unix or Linux utilities into the router. It's going to create some configurations for Nginx and set up the bind, the DNS to run as a service. It's also going to format that micro SD card we have plugged into it and use that as the persistent storage for all this configuration that we're setting up. All right, this one will also take a little bit of time to run. So you can see it's going out to the GLINet release of OpenWRT, and it's pulling down a bunch of packages to install. There's the bind stuff, libfdisk for doing the disk formatting. Lots of tools there. It's creating the partitions on the micro SD card. And it's going to create a file system on there. This will take just a little bit. I won't pause the video this time though, because there are things to watch while it's happening. Once it completes doing this table here, see, it looks like our network dropped for just a minute. Let me make sure we're still connected and that it's still good. Yep, there we go. Yep, we're still good. We're still connected. Okay, that's creating the journal and the file system. And when it's done with this, it's going to reboot again. All right, almost done with our file system. There we go. You can ignore that UCI entry not found. That was actually looking for a configuration if this had been set up a slightly different way. Now it's going to install a few more utilities. Same thing, you can ignore that UHTTPD. That was for an older version of a router. Okay, and it's done. Now the router is rebooting. So again, we're going to watch our network connection here because it's going to drop. And we'll wait for that router to light up again. And this time when it comes up, it should be fully configured for our lab with DNS setup and everything ready to go. So we'll give this just a minute. Router usually takes between 60 and 90 seconds to reboot. We should see my MacBook pick it up here again in just a minute. And there it is. Okay. Now I'm not going to click on this right away because when it first shows up and it's transmitting beacons, it does actually go through another cycle where it drops the wireless and then starts it back up. So I usually give it just a little bit before I go and reconnect. Okay, I'm also going to go into my Wi-Fi settings here and make sure that I have this guy right here set to auto join so that if I do hit a hiccup, it will automatically connect me back. And there we go. We are connected. Let's make sure we can ping the router. We can ping the router. Now, for the moment of truth, let's make sure that DNS is working. And there it is. DNS is indeed working. Let's make sure that wasn't just a cache. It was not just a cache. All right, so our router is set up now. I'm going to log into the router real quick. Saying SSH root at 10.11.12.1. It says, hey, wait a minute, there's a host there with the same fingerprint, 192.168.1. You sure you want to continue? Yeah, because I know this is the same router. So I'm now shelled in. The DNS set configuration is actually in user local bind. And user local is the micro SD card that you installed. So that's in there to give us more storage to persist these configuration things. And you can see here the named.conf is your primary configuration file for this DNS setup. And all of this was constructed by the scripts. So you can take apart these scripts and look at how this configuration is built if you want. The db.my OpenShift lab, that's where your A records are going to go. And then the db.12.11.10, that's where your reverse lookup records are going to go. You can see right now there's only one entry in here, router.myopenShift.lab. If I log out of the router and I ping router.myopenShift.lab, I should see that I am in fact resolving to 10.11.12.1. So bind is working. Bind is now providing DNS for our lab. We are now ready to start the OpenShift installation. So to get that going, the next thing is to run another lab CLI command to deploy the OpenShift cluster. This one's going to do a whole bunch of work for us. When I run this, it's going to use the OpenShift install command, and it's going to point it to some files that it's going to generate, some YAML files. It's going to create an OpenShift install file. It's going to create some in-state YAML files that it will use to give it an opinionated network configuration on the node when the node installs. It's also going to create the PXE boot artifacts by downloading an ISO image that is part of the artifact archive for this OpenShift cluster. So you're going to see this do a whole lot of work here. It's also going to create DNS records in the router for this OpenShift cluster. And if this were an HA cluster, 3 control plane nodes, it would also create the Nginx load balancer configuration in your router and set up the DNS for your router's load balancer to sit in front of the OpenShift cluster. Since we're doing a single node install, it's not going to go through that effort. Okay, this is another step that's going to take a minute or two, depending on the speed of your internet connection. So I'm going to pause the recording here for a moment, and I'll come back when this particular command has finished. All right, see you in just a bit. Okay, I'm going to unpause for just a minute because it's completed that first step, and now it's pushing the PXE boot artifacts over to the router. So now it's doing file transfer from my local workstation to the router to push those artifacts over that are going to be used to PXE boot this node. It's now completing the configuration in the router and now pushing the final artifacts across. So again, this is going to take a little bit of time because the initial RAM disk is pretty big. So I'm going to pause the recording again, and I'll come back when this finishes pushing across. Okay, so the configuration to get everything in place to install our OpenShift cluster is now complete. You can see that, let's see, do I have the size of that initial RAM disk? It was pretty big. That root file system there, you can see, is just over a gigabyte. So the init RD is actually split into two files. The RAM disk itself, and then a root file system. So what we're going to be pixie booting off of is actually a complete Core OS operating system that contains everything to start the installation process for an OpenShift cluster. So the next step here is literally to power on the little Intel NUC. I use Wake on LAN to do that, just for fun, especially in a situation here where the whole setup is sitting away from me, and um, I don't want to reach over and push the power button. So what we're going to do next, I'm going to get the camera on the machines over there so you can see what's going on with it, and we're going to start this installation. All right, so I'm going to pause for just a minute, make sure everything's set up properly, and I'll be right back. Okay, I think everything is set up and ready to go to run this command. Lab CLI-start-C is basically fire up the cluster. In this case, it's less interesting because there's only one node to start, but in instances where I have, you know, a 9 node or a 12 node cluster, it is kind of fun to watch all those machines light up all at once when I run this command. What I'm going to do is I'm going to actually pivot this over to my iPhone camera that I have set up, where I have the NUC with the router we've been configuring, and I've got a monitor, like I showed you in a previous video, plugged into that. You won't be able to see a ton of interesting stuff on the monitor, but you should be able to see it go through its pixie boot process. And if you watch the NUC, when I hit the return key here, you should see that that little power light just lit up. And in a minute, if that monitor picks up properly, we should see the Intel NUC display on the screen, and we should see this little guy start to initiate a pixie boot. All right, and there it goes. It's now configuring the network, and there you see now it's downloading the artifacts, and it just started booting that Core OS instance. And it's going to configure its network, and it's going to set up itself to start the pixie boot process. Now, I'm going to bring you back over here to the screen for just a minute. In fact, there it went. I think it just did its reboot. So the next thing's in here. This lab CLI -- monitor -B, that's actually a way that we can monitor the Bootstrap process while it's happening. Because you'll see here, it's not going to do a ton of interesting stuff, but it will give us progress. If I pivot back over to the iPhone camera, there, that blue screen you saw, that was the final stage of it configuring its network. And it is now booted and up and running. If I come back to my screen share and I open another terminal window, should be able to ping that machine and see that it is in fact up and running. There's another command that I provided for you here, lab CLI -- monitor -m equals 0. That's master node, the 0th one. This is just a convenience utility I put in place to allow you to tail the journal on that machine. So even before you start to see stuff happening on the left-hand side, which stuff just started happening, you can also watch the journal on that machine to see activity. So you see we're waiting for host to become ready for cluster installation. This is the preparation for the Bootstrap process. This machine is going to write the operating system to disk. After it finishes download, what it's actually doing right now is it's going to Quay.io and it's pulling down the image artifacts for the OpenShift install, and it's going to get those, pull down or extract from them the disk image for the Red Hat Core OS installation. It's then going to write that to the disk and then reboot and pivot to that version of the operating system to then do the Bootstrap process to get the cluster installation going. You can see right now it says it's preparing for installation. So at this point, you can go get a cup of coffee, go make yourself a whiskey sour, whatever you want at this point, because now we just wait for the installation to complete. So I'm going to pause the video at this point, and we'll wait for the Bootstrap process. When it's finished, the command that's running over here in this left terminal is going to complete. And at that point, then you can run the lab CLI -- monitor -I to watch it finish the installation process. Okay, so I'll come back when Bootstrap is done, and we'll fire this up and we'll keep watching it through the rest of the install. But at this point, it's basically just go away and wait for this to finish. Depending on the speed of your network and the speed of the Intel NUC or the Intel machine you're using, it could be anywhere from 15 to 30 minutes. Because this is relatively fast and my home network isn't too shabby, this will probably take about 20 minutes to complete. All right, see you back here in just a bit. Okay, I'm going to point out a couple of things while this process is running. You'll see here the Bootstrap Kube API is initialized. The Bootstrap process is now running. Now over here, if you're tailing the journal logs, don't be alarmed if you see entries that look like errors. Remember, Kubernetes is an eventual state system. It's an eventually consistent state system. And so you'll see processes here that are waiting for resources that don't exist yet. So like this failed to create. Don't worry about that because it will eventually complete. It's waiting on dependent resources, but everything's running in parallel. That way, nobody has to monitor somebody else's status. It just everything tries to run at once, and as things complete, then things that are dependent on those things can use the completed state to continue their own processes. So it might look a little messy while this is running, but it's actually a very efficiently engineered system so that it will continue to retry until it achieves the state that it wants to achieve. All right. So this is going to take a little while for it to complete that. I'm going to pause again and I'll come back when this Bootstrap process finishes. All right, I'm back again. Actually, I came back before the Bootstrap process completely finished because I wanted you to see that this machine wrote its final OS disk image to the disk and then rebooted, which is why this tail of the journal logs stopped. And if I pop over here again and show you, you'll see the machine is now booting back up with its final OS image. And once it gets back up and running, it's then going to complete the OpenShift cluster install. So we're pretty close now. We've just got a little bit more for it to do to get its OpenShift instance completely up and running. And I can restart that journal log here. And you'll see that it's going to start continuing what it was working on. And here in just a minute, this left-hand terminal is going to exit and tell me that the Bootstrap process has completed. So I'm going to pause again and I'll come right back. All right, something else I'm going to show you. You see this fetching OS tree chunk stuff going on? This is that second phase that I was telling you about. It's now pulling down the core OS image from the OpenShift release that we're installing. You see this quay.io, OpenShift release dev, blah, 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 blah stuff with a big digest hash. And as soon as it finishes pulling this down, it's going to move on to the next phase of completing the installation. It should be getting pretty close here. So I'm going to pause the recording again so you don't have to watch too much of this, and then I'll come right back. Okay, here we go. This is now the final reboot of the system. If I come over here, you'll see that it is indeed cycling a boot. And when it comes back up here in a minute, it will have completed the Bootstrap process and will be ready to go on to the phase of completing the OpenShift cluster installation. And there it goes. So you can see in the screen there on the monitor plugged into that box that it's booting back up now. And you can see on my screen share that the tail of the journal file again exited because it booted. So we'll reconnect to that. And we're going to have to wait for it to get its network activated. There we go. All right, so it's got a little bit more work to do now with this new OS image as it starts its final phases of the OpenShift install. And here in just a minute, it should record its Bootstrap complete. Again, you'll see some things in this that look like failures. Don't panic. Unless they just start repeating over and over and over and over for quite a while, you can comfortably ignore those. Like I said, it's an eventually consistent state system, and so it runs things waiting on the dependencies for other things. Like here, you see all those connections were fused. It's waiting on a service to be up and running. The log is going by too fast for me to tell you specifically which service it's waiting on, but you can tell now that more things are starting to happen based on the disposition of the logs. And there we go. Left-hand terminal. Bootstrap is now complete. So if you run labcli -monitor-i, and let me clear this screen out so you can see it closer at the top of the screen. That will run another command that monitors the installation completeness. And so now we're in the final phase. I'm going to pause the video again because this will still take a few minutes for it to complete the installing of the OpenShift cluster and get all of the base operators in a healthy state. And when it does, I'll come back and we'll get this cluster set up to do something useful. Okay? So I'll see you back here in just a little bit. Okay, I'm coming back for just a little bit to tell you this is probably taking longer than you feel like it should, and you're watching the logs and it looks like there's lots of errors. Trust me, everything is okay. In fact, I'm going to show you a little trick here while we're waiting for this to do something. I'm going to go ahead and open a new terminal window. Okay, I'm going to pull it down here in front. There's a way to peek in closer to what's going on, run labctx and choose option 1 because we only have one cluster. That's the one we're going to manage. And then type lab env-k. This is a break glass command that sets your kube config variable to a kube config, sort of a secret admin kube config that's created when the cluster is installed. That logs us in effectively. So now I can do like an OC get nodes and wait here for just a second for the API to respond. And you can see that in fact, my node is now in a ready state. And that it is both control plane and master at this point. The OpenShift cluster itself is still installing. If I make this window a little bit bigger and I do OC get pods -- all namespaces, when the API responds here, you'll see that it's still standing up a whole lot of containers. It's got a lot of containers or pods rather, in the pending status. It's got some that are initializing, and so it's still standing up all of the core components of the OpenShift cluster. So this is the part that takes a while, just needs a little bit of patience, especially if you're watching the journal fly by. It looks like errors are flying all over the place and stuff isn't working. Don't worry about it. In fact, turn off the journal log if you want, and just come back later and take a look at it, and I promise you the installation is going to complete. Okay, so I'm going to pause again and I'll be back here in a bit. Okay, I'm back for just a little bit because our installation is progressing. I just also want to point out, if you're monitoring the install progress, don't be alarmed when you see debug statements like could not update role binding, blah, 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 or couldn't update service account or things of that nature. Again, that's part of the eventually consistent nature of this thing. It's recording these activities. There may be a way to turn off the debug messages in this, but I've never bothered because if you understand what they are, it will complete. The other thing that you're going to see occasionally is this percentage complete will sometimes reset down to a lower number. It's always done that. I don't know why it does that, but when it does that, don't let that alarm you either. As long as things continue to be progressing here, it's going to be okay. And here in just a few more minutes, we should have a up and running OpenShift cluster. All right, I'm going to pause again and I'll be right back. Okay, our installation is getting really close to being done. Something else I'm going to point out here is that these lab CLI -- monitor commands, they don't actually impact your installation. So like, for example, in this left-hand terminal, if I control C that and then restart it, it's not going to have any negative impact. It's literally just monitoring status from the Kube API to see where OpenShift is in the installation process. And here in just a minute, we should see it wrapping up. And on the left-hand terminal here, it's going to spit out the final configuration information for our OpenShift cluster for us to log into. Once that's done, then that'll be the end of this video. And in the next one, I'll show you how to do some post configuration and get the cluster set up to be useful for deploying some real applications. All right, so I'm going to pause again while we wait for this to finish, and I'll be right back. Okay, cluster installation is now complete. That actually took a little bit longer than I was hoping that it would. It looked like I was having some latency issues pulling images from Quay.io perhaps. But the important thing is the installation did in fact complete. And if you will look now here at the bottom of this terminal, you can see that it's output some information for you. There's the kubeconfig file that it stored for you. Here's the URL to your console. And here's the initial password that it created for your kubeadmin user. Okay, so that's going to bring us to the end of this video. In the next one, I'm actually going to show you how to do some post-installation setup and create your own user account. So we're going to actually delete that kubeadmin user. But in between now and then, you could point your browser at this console. You'll have to trust the certificate, which I'll also show you how to do with one of my utility scripts, because you're going to get that. But I'm going to wrap this one up for now, and I'll see you right back here in the next video where we'll set this cluster up to do something useful. Okay? I'll see you in just a bit.